Hey, hello guys. I'm making this video just to let you know that sadly the amplifier that I was making a redrawing. Basically, I was just copying the same circuit. I'm going to show you the circuit. Sadly, even though I made a nice PCB and looks really nice and everything, looks pretty. It actually looks pretty awesome. But sadly, I tried to simulate the circuit today. Actually, sorry about that. Today, I was working on the circuit to try to figure out what is wrong with the circuit. So this is the Cobra 250, and I tried to debunk or find errors and stuff like that. I tried all combinations of resistors and stuff like that. I was thinking that I made a wrong connection, and I look at the schematic like 5 or 10 times and trying to figure out. Don't worry about that. That's my gaming channel. So here is the schematic of the circuit. So what I did, I just as you can see, what I did is copy the whole circuit into my multi-sims program so I can simulate the circuit. I was thinking that I probably mismatched a transistor, or probably I made a wrong connection, probably a wrong value resistor, and I tried many times and still have the same error. So this is from the www.dysmps.com, and I tried many times and it still have an error. So I'm not sure if they made it work somehow. I don't know how they did it, but this is the result that I have. So I wanted to show you guys. So I cannot continue this project anymore. So sadly, even if this layout looks pretty good, I cannot continue because I'm not sure if there is an error on the schematic. So right now I'm going to show you the results. Right now I have 1 kilohertz, 1 volt peak, to see if I can get the. So this window, this little window here, is it measures the total harmonic distortion right now. I got 36.8 distortion. That's pretty bad right there. This one here is the oscilloscope. As you can see, that's a wrong bad signal. I'm not sure what happened. I'm not sure. And this little window over here, it measures the power in watts. So I'm going to activate the simulation, and I don't think that I made a mistake because I have done this many times, so I should not have any error on this circuit. So as you can see, that's pretty bad. So I do not know what's going on. I tried to adjust the bias. I try to figure out, maybe I place a wrong connection like I said before, or maybe a mismatch component, a wrong component. So it's the same circuit as this one here, and I look at it like many times and trying to figure out. I was thinking that I need to install this. I'm going to show you right now. I was thinking that I needed to install this D3, the diode, the C10, T9, T10, C11, and D4, and then D6, and R18, R17, and D5. I was thinking that I need to install those so in order to make the circuit work. So it's not working. So so this project, even if the project looks pretty nice, I cannot share this. So sorry about that, because I know there is an error on the circuit. So I cannot share something that I know that might give problems. So I'm not gonna share this one because it probably have something wrong with the. Let me put an X on this. There is something wrong with the circuit, and I don't know what it is. So I'm going to try, if I can. I'm gonna place an X on this circuit. I'm going to try to check it one more time today. If I don't see that I can find the error, I'm going to delete this file and not to share, because it's bad. It's bad. It's not good. So I cannot share some. That's why when I post stuff on my Facebook page, please do not ask for the PDF right away, because I like to first. Well, that was my mistake. I should first simulate the circuit, find out if the circuit works pretty good, and then do the layout. So now I waste like 4 days making this layout for nothing. So now it's not good. So it's sad. It's sad that I spent many hours try to make it look good. You know, something that you will be happy to build yourself as a DIY amplifier. So I cannot continue making this layout. This one here in particular. So what I'm gonna do, I'm going to let's say recommended other circuits that I know that are pretty good. Right now, this one here, probably you guys already seen this or not. If this is the first time you've seen this circuit, this is a pretty good design. This one is made by Mr. Pete, alias O Stripper from DIY.com, and Mr. Betmira, he knows this circuit too, so he also knows about these circuits. The good thing about this circuit is that you can have the power board separate, and then you will choose your IPS driver board. I know that in Philippines they call it driver board, probably, or other people they call it in Spanish a tarjeta driver. That's the driver card. That's the way they say. As you can see, I have on this simulation, I have 5 pairs of power transistors, and I have the low is, I think it's 4 ohms right now. On the testing, it's 4 ohms low, simulating the actual low of the speaker. And the input right now, I have 1 kilohertz and 1 volt peak, just to test the output. This one is a pretty good design, and it can give a lot of power. But you gotta be careful, because you will need at least let me see, 85 volts on the DC to get that power, so without distortion. So right now I'm going to activate this simulation. So what I want to do, I'm going to try to see if I can find the PCB that is a single layer PCB, not double layer. The problem with the double layer is that you have to order the PCB to the manufacturer, so that might be really difficult to do. So some people cannot afford to pay for the manufacturer. So right now I'm going to show you the file that I have here. Okay, this is the power board. As you can see, I do have this power board. I ordered this board last year, probably last year. So I'm going to show you the pictures right quick. Let me see, pictures right here. So this is the power board. I have not completed this project yet, so it's not done. The other day I was installing the emitter resistors, so I complete all of them. So this is the bias. This is the bias transistor Q1104, and this is basically the driver that drive the power outputs of this amplifier. This is a pretty good design. I wish I had more money so I can complete it. I spent a lot of money on this. So right now I'm going to show you the driver board. Let me see, I think it's over here, the driver board. This is the driver board. I tested. Oh, it sounds amazing. It's a pretty good sounding driver board. So right now there is more IPS driver boards, so I'm going to show you. This is the driver that goes with this simulation right here. So I'm going to activate the simulation so you can see how many watts you can get. Basically I have in the watt meter, wattímetro in Spanish, wattímetro, I got 540 watts right now, and the total harmonic distortion is pretty low. I got 0.006% total harmonic distortion. So this is a pretty good design right here. There are more circuits for the Slew Master. This one here, let me see, that one is the same. Okay, let me show you another. This is the newest output power board, but I did not like this circuit for one reason. Maybe it's too difficult for me, probably, I'm not sure. Okay, this is another Spooky. The Spooky driver board is basically let me see if I can remember. I really forgot. This is a pretty good design, but I really forgot the topology. Okay, I'll let you know later if I can remember. Okay, this one is the small power amplifier. This is MOSFET, one pair, and it sounds pretty good. I already tested, and it's a pretty good design. So just to let you know that this is the day I was testing the MOSFET with one pair, and this is the Wolverine Pretty good, pretty good. And I was using, I think it was only 43 volts, 43 volts. So DC coming out from this. I think this transformer is 35 volts AC, and I get like 43 volts. So it's pretty good. It's pretty good sounding amplifier, and it's pretty small, so it sounds pretty good. So my recommendation, I think this will be a nice design if I can find a single layer of this amplifier. I will share on my Facebook page so you guys can see. And it's pretty good. It's pretty good. Let me see from this project. Let me see if I can find another. So that's the output. Okay, this version is a 2-pair. I think this will be easy to make it as a single layer. The only thing I gotta do is find out where to place jumpers here. So I might be adding some jumpers here. So you can one sample right here. You can place the pad. I think if I can do that, place the pad here and another one here, so I can eliminate the double layer. So right now I'm gonna do that right now. So right here, pretty good. And then just place a line to show that it needs a jumper, a wire. So you're gonna place it right here, and then make it thicker. So I'm gonna make it thicker so it looks good. Let me see, 80. I think it should be 70 is okay. And make this line S1. So that's for the jumper. So I can eliminate that red. This red trace means that the copper is going to be on top of the circuit. So let me save that. So I'm going to try to share this one here. This is you can get two pairs with this one here, and I had to make some changes. Okay, there's another. Okay, right here. I think I can make another jumper. I hope you guys can understand my English. My English is my second language, so I cannot. Okay, let me see if I can. I might be able to add this pad here, so it can be. Okay, I think I can do it. Let me see, 1.57, 1.50, just to get jumpers. I mean to eliminate this trace, so you guys can try it out. This circuit. Okay, I think I need to. Let me hide it. Oh, okay. I'm gonna hide the C1. Okay, I need to complete the circuit here, so I'm gonna do that right now. There you go. Here I think I can make another one. I make it thicker. There you go. So it can be just using jumpers. Okay, this might be too close to the. All right. Oh, this is just an example. I'm going to try to upload this later, making this circuit as a single layer instead of double layer, so it can be used for you guys. So you want to try it out. This is a pretty simple circuit. These are the small drivers. Oh yeah, also the schematics, pretty important. The schematic for this PCB. I do have those. Don't worry about that. Don't worry about you don't see the component. I think I do have the. Oh, there you go, right here. This is the driver board. There you go, right here. Pretty simple to use. As you can see, it has all the jumpers, and I need to find the schematic and put it together so I can share this for you guys. So you want to try it out. It's just pretty simple to do. You can see if I take the C1, you will see all the jumpers that need the circuit. This is a pretty good circuit right here. Let me see. Right here. Let me see. I think I have the. Let's see. Probably this might be a bit different. It's a CFA-X-HB version 1.3. So let me see. Yeah, it is that version. So it's pretty good. It's pretty good. So what I'm gonna do, like I say, oh man, I talk too much. I'm gonna put all together with a schematic with this circuit and the output power board. This one here and probably the big one too. I can do the same thing with the big output power board. This is the power board where you're gonna install all the power transistors. So I'm gonna give you a example of this, or so probably if you don't understand my English, you will see as a vision what I mean. I'm going to right now make a width thick. Advice, please, if you're gonna make this, don't use it to sell it. Please don't do that. Do not sell this. Only for your enjoyment, not for sale. So please do not sell this. Okay, let me see. Okay, I think I can use this one. No, that's a MOSFET. I cannot use that. That's a MOSFET transistor. You're wondering why Mr. Juan Vargas is doing this? Because when I started to learn about audio amplifier circuits, there was not much information about what to do, where to find the good circuits. There is many circuits online, but actually there is not many people that actually study it and trying to figure out how the circuit works. I'm not an expert, but at least I can get through how to build a computer. I mean, a computer. I also build computers too. Sorry about that. Build an audio amplifier. I already built like probably seven audio amplifiers. I have not tried Class A yet, or Class B, and Class D. I have not tried those. I'm working more with Class AB. So this one is Class AB audio amplifier. Let me see if I can find the. I need to find the output power transistor, so to show you as a vision. Visually, that's a word. Visually, there you go. These are the one that I need to just to show you what I mean. So this a popular Toshiba transistor. Many people use Toshibas. There you go. I'm gonna split the group just to show you as a vision what to do. So you will install all the power transistor like this. You gotta make sure you have insulated with thermal paste and all that stuff. Probably Benmira will be like, oh man, this guy is crazy. That's okay, Mr. Benmira. I like to do this. I mean, I do not mind to show what I mean about. Okay, so the only thing I gotta do is copy this as a vision. So I gotta use this here. So this is the way you're gonna install all the. What the hell am they here? I made a mistake here, so I gotta install it right here. There you go. So that's the way it's gonna look like. You can see this is just an example. So all transistors will be attached to the main heatsink. Make sure you got all them really nice and insulated. Also here on this part of the circuit, as you can see, there is a line right here. As you can see, there's a line. That line means that you need to install a small heatsink just for these drivers. This QA and Q7. Q104 is basically the bias transistor as the Q103. Q103 also will be attached to that small heatsink together with these two driver transistors. Make sure the Q104. Also, you can use wires. If you don't want to install it that way, you can install it by wire and place this bias transistor. You can install it on top of one of these power transistor, or probably separate right here. You can place it here and with a screw insulated, so you can try it out this power board. You can see this is the connection, how you're gonna connect. This is the basically ground. This is the negative, the ND, PD, and positives for the supply for the driver board. And this one here is really important. This connection here is a negative feedback. That one is really important to connect by wire, so it will be connected. Let me see if I can find the older one. So this is the negative feedback. It needs to be installed right there, so don't forget to install that wire right there into the negative feedback. Sorry for the guys that only speak Spanish, so today I had to make the video in English, but probably some people will need to know this in English, you know, so they can understand, you know what I mean. So right now let me go back to show you. So here are the connections, and then this wire is really important. This ground connection goes right here, so I'm going to show you as a wire. This is going to be just an example, so don't worry about it. So I'm going to trace trace just as an example wire. So this one here will be connected. I should change the color right here. As you can see, this is the ground, so it needs to be connected underneath the PCB. So you're gonna connect that wire. So let me change the color. Let me go with green so you don't get confused. As a ground, so that one will be C2. As you can see, there you go. So that's the way it's gonna look like. The wire needs to be connected right there, and this wire is a negative feedback. So what I'm gonna do, as an example, I'm going to make this PCB. What the hell I did here? Don't worry about that. Okay, gotta make this the size so I can place the driver board there as an example. So this is the single layer. Copy it, and then I'm gonna place it besides the. So it's gonna look like this. Let me see. So this is the power board, and let me see. I'm going to. I think I gotta. Let me see. I'm gonna do it this way, so you guys can understand better. I'm gonna rotate it. Oh, okay. I did it too much. I overdid it right here. So you can see. So these are the connections that you gotta do. So what I'm gonna do right now, I'm going to place this on top of this. Let me see if I can get that grid. There you go. I got a grid. All right, I'm gonna move it. So that's the way you're gonna connect it. Place the wires here. This is just an example. Don't worry about it. So it's going to be connected like this, as you can see. And then the negative feedback that this wire is really important is going to be this one. Sorry about that. This one here. It says NFB, negative feedback. So right now I'm going to connect it to negative feedback of the audio amplifier. The power board. So it's going to look like this, and here is going to be connected the audio input. As you can see, the signal from the radio or CD player. You got a negative and the positive here. So this is going to be the positive connection right here. I'm gonna change this to red, so you know what the hell. So I'm going to change this to C1. So that's red and the ground. So, and this is the input capacitor for the circuit. So it's a pretty good design. Mr. Timios made this prototype, and he says it works pretty good too. The same thing will happen with the other driver boards. Sorry that I'm making this video too long, but this is really interesting to have this data on YouTube. So this one is a redrawing of myself from the Wolverine. This is a single layer. This one I think have the values. I think I have the values here. I'm not sure. Let me see. Let me see if I can find a different circuit. Let me see. Spooky. Let me see. Okay, this one is the Wolverine. This one was designed by Mr. Mr. Pete. And this one also is another alternative that you want, another type of driver for your circuit. So this one is pretty good too. Basically, it's about the same topology as the Honey Badger. The Honey Badger that he designed. So basically, is the Wolverine is basically that, the topology of the. So I'm gonna place it over here. So yeah, the same thing is going to be happening with this one too. It's about the same thing. You can see if I remove this, I can select a different topology of audio amplifier. So okay guys, I'm gonna cut the video. I think you guys got it now. So these are two great designs that I already simulate this one here, but I have just a little problem, but I don't think it's a big deal. Probably it's the software, that maybe a mistake from the software. So I really don't worry about too much, because I already tested the amplifier and it's pretty good. As you can see, this is the IPS driver board, and it works pretty good. I think that it maybe, like I say, maybe it's a error from the software. So I'm going to simulate it right quick. So as you can see, this is the error that I have, but probably it's not a big deal. I don't think it's a big deal, because it's actually working right now. So I'm going to simulate it right now, so you guys can see as you can see, that's the little error that I have. Maybe something else, because the circuit works pretty good. So maybe something. Maybe it's not a big deal. but it's actually working. So sadly I had to say that I cannot continue this one, Cobra Amplifier 250. So I hope you guys can understand that, but I will try. If I can, I analyze it one more time to see if I can find the bug or the fix for the simulation. So the Cobra 250, it's sad. It's sad. I spent many hours and days working with this. So alright guys, have a good day. I hope you like this video. If you like this video, please subscribe to my channel and give it a like to this video and share. Probably someone would like to learn stuff about PCBs and audio simulation on software. Alright guys, have a good day.